Using the graph, we are going to see how to make a network flow. Let us take a graph. So you all know how a graph looks like. Say for example, let me take a graph. For instance, a graph may be looking like this. Maybe with some vertex S, U, T, and V, and every vertex may be connected by edges. And here I have to, I'm going to give weight for that edges as well. And this is a directed graph. Okay, so you consider this is a graph, and every graph we know it has edges as well as the vertex. So now, what does this network flow diagram problem means? For example, you consider this as a network where I want to send some data through this network. So if I want to pass some data through this network, what I can do is I cannot directly uh, so for example, 2 specifies how much data I can send from S to U. And what is 1 specifies how much data I can send from U to T. Or you can consider this path as a pipe. Okay, so you can consider this as a pipe. So here it's like I can able to send a volume of 2 data. Here this is also a pipe only, through which I can able to send a volume of 1 data. Okay, 1 amount of data. Through this way I can able to send a volume of 3 amount of data. That is the meaning. So that is what this numbers specify on this edges. So, for example, we are going to transfer some data from one source to one destination. So, in this case, you consider in this diagram, let us consider this is our source and this is our destination. Okay, this is our destination, and this destination can also be called as sink, or you can also call it as target, whatever it may be. So what is my objective is I'm going to start sending a data from the source to destination. And something more you have to note here is for this no source node we don't have in order will not be there. And here if you see in the sync node, we don't send anything out of this node. Okay, so nothing will be coming to this source node and nothing will be going out of this sync node. So that is what the condition we'll have when we want to send some data from one node to other node. So that will be our source and this is our destination. So no data will be coming inside to the source and no data will be going outside of the source. So nothing is going outside of T. And here you can see nothing is coming inside of S. So this is what the source and destination is. So now what we want to find is what is the maximum flow I can send through this network graph. Okay, so what is the maximum flow? That is what I want to find. So I want to find the maximum flow. So you can see every path may be having a different capacity of the pipeline. Okay, so this pathway, this pipe have a capacity of 2, this path have a capacity of 1, this path have a capacity of 2, like this. So you cannot like for example, if I send a amount of 2 volume of data through this path, so I will send a 2 volume of data through this path. But you can see that same 2 amount of volume cannot be sent from U to T because this path is capable of only accommodating 1 volume of data. And one more thing you have to remember here is U doesn't have any storage. Like you cannot store some one volume here and the other volume can be sent through this. That is not possible. So storage is also not possible. So it is like a flow of data. So so you have to find if I send 2, it should start from source and it should reach destination without any interruption. So say for example, if I start, for example, if I am sending a 1 volume of data from this source, So here there is no problem because it can accommodate two. So one also is possible to send to S to U, and from U to T already the capacity is one. So sending one volume of data is not a problem. So you can able to send it. So for example, you consider I want to send a 3 volume of data. Okay, is it possible to send a 3 volume of data through the path of S to U? Which means no, because from S to U, you can only send a volume of 2, right? So we have to find, so what is the, why we have such problem is all the pathways of not same capacity. So our problem in this network diagram is we have to find what will be the maximum flow. Okay, so that is our problem. Let us start solving it. There may be many different ways to solve this. Let us see one by one. Okay. So first of all, let me start it by. One second. So let me to start with. So let me start like this. So put a slash over all places. So you can draw a different diagram also for this. Otherwise, I'll do a different diagram instead of writing everything here. Let me make one more network diagram to make you to clearly understand. So same network diagram I'm going to draw. So this is U, and from U we are going to T, and with the capacity of 1, this is of the capacity 2, and here we have a flow 1, and here we have a flow with the capacity of 2. So what we are going to do here is, so if it is a forward path, okay, if it is a forward path, then what you're supposed to do is you have to add something along with that. So say for example, if this is an xij value maybe, so if it is a forward path, you have to add the value, okay, and if it's a backward path, then you have to do the subtraction. So you have to keep that in your mind. So backward edge means you have to do the subtraction. If it is a forward edge, you have to do the addition. So initially we are not sending anything through this path. So initially 0 is there. Okay. So now there is another path through this also. So initially nothing is sent through this path. So initially we have 0, 0, 0 everywhere. Here is also 0. Okay. Nothing is sent initially. So now what we have to do is we have to find a path. So here we have one path to reach from source to destination. So this is our source and this is our destination, or we can even call a sink. So to start from source and to reach destination, we are going to find a different path. So one path is moving from S to U and from U to T. So that is the one path, and we have to find what is the flow we can send through it. So how you have to find is, say for example, you have to do 2 minus 0, this one, which is equal to 2, and 1 minus 0, which is equal to 1, which means its capacity, right? So among these two, which is the minimum value we have is 1. So this is the flow, which means if I send one volume of data, I can able to send through both the paths. So we have to take the minimum. So 1 minus this 0 and this 2 minus this 0. So that is, so which we have the minimum value out of this 2 and 1, we have the minimum value is 1. So here we have to take the flow as 1. So to this, through this path, we can send a volume of 1 data. So now after, so I am going to take the flow as 1 for this path. So since I have taken the flow as 1, I am going to update this. So I already we saw if it is a forward path, we have to add this 1 to this. So if I add 1 to this, this will be updated as 1 divided by 1 slash 2. Here again I have to add with this, so it become 1 slash 1. So if it is a forward flow, then you have to add this flow with it. So I am adding 1 to it. So 0 plus 1 is 1. So slash 2. So what is the meaning is, out of 2 volume of data, we are sending 1 volume of data. Here the path, the out of 1 volume of data where I can able to send through it, I'm sending 1 volume. Okay. So this is one path through which I can able to start and reach the destination or the sink. Okay, let us find the next path as well. So if I find the next path, what is the other way I can send? I can go from source to destination to send this flow of data. Other way I can take like this. I can start from yes and I can go to V, then I can reach the destination T. So the path will be like I'm going to start from the source yes, go to V, and then I can go to T, right? So this is another path to reach the destination. Now what we have to do, we have to find what is the flow through this path. So to find the flow, what we have to do, we have to subtract it, right? So I'll say 1 minus 0, which means this 1 minus this 0. Okay, so available capacity is 1. How much we have used is thus far 0, so that is 1 minus 0, that is 1. And here also, out is available capacity 2, how much we have used thus far 0. So that is what, to make you to understand, I am writing 2 minus 0, which is 2. So then what you have to take out of this 1 and 2, you have to take the minimum value. So we know the minimum value of 1 and 2 is 1, which means if I send a one volume of data, it can be sent through this pipe way. Also, I can send it through this pipe also, because there will not be there we have a enough capacity to send one volume of data. Say for instance, if I try to send a two volume of data, definitely this is not possible, because this pipeline have a capacity of only one volume to accommodate. But this way I can send, but here I cannot send, right? So through this path we found you can able to send a flow of one volume of data. So that is that. So then what you have to do, this one, since it is a forward flow, what you have to do, we have to add this one to this one, to this, right? So if you add it, so how does it update? It will be like 1/1, and here it will be like 1/2, which means the flow which I can able to send is 1, which means out of one capacity we are sending 1. That is why we added it. Here also 0 plus 1 is 1, which means out of 2 capacity we added 1. Okay, so what is the remaining capacity then we have, if you want to say 2 minus 1? So 1 will be the remaining capacity. So this is one path. Okay, so we found two paths. So this is the first path and this is the second path. Let us see, is there is any other way through which we can able to reach the destination. So we send through this path, we send through this path, and again we have to find, is there is any other way I can able to send the data simultaneously. It's a flow of data. Okay, so everything will be happen at the same time, and I have to send the data through all this path, and I have to say how much minimum amount of volume I can send. So if you see here now, you can see through this way, can I send data through this way? No, because already the capacity is 1 and that 1 is already used. So this place is blocked, because through this way we cannot send any more data. Can we send some data? So only out of source we can send by two ways. This path is blocked because out of one is used. And can we send some data through this path? Yes, definitely yes, because the pathway is capacity is 2 and we have accommodated 1. So what is the remaining capacity we can have is 1. Okay, so the remaining capacity is 1, which means here you can say 2 minus 1 is 1. So one more capacity is left. So I can send data through this way. And can we send data in the same way again? No, because here the capacity is 1, it is already used. So this path is also blocked. So I can send the remaining capacity we have is 1, okay? And through this way I can send, but this way is again blocked. So I cannot send anything through this way. So we have to find the next path. So here we have another path. So U to V. So here the capacity is 3. It is not used, so we can send through this path. And if you see here, already the capacity is 2. 1 is already used. So what is the one more capacity we have is 2 minus 1 equal to 1. So one more capacity is there, so we can send it through this way as well. So what is the next path we have? The third possible way we have is, I can send from S to U, and then from U to V, and then from V to T. So this is another way, right? So This is the third part I can use. Now I have to say what is the flow of it. How will you find the flow? So again we have to do the subtraction. Already we did the subtraction here. Out of 2, 1 is used. So 2 minus 1 is 1. And here also we have to do it, right? Which means 3 minus 0 is 3. So this is the next place. And here again 2 is there. 1 is already used. So 2 minus 1 is 1. So here also we have 1. So then what you have to do, you have to take the minimum of all these 3. So what is the minimum of all these 3? Here we have the capacity of 1. Here we have 3 and here we have 1. So out of all this, the minimum capacity is 1. So through this path also we can send a flow of 1 volume of data at a time. So that is also we found. So after we send a 1 volume of data, again we have to update it. So when I update it, how does it change? Like, so now since we have sent this 1 again. So already 1 is there. Now we send 1 volume of data. So what will be there? 2 by 2 is used. And here we will be updating is out of 3 volume we send 1 volume. So we have what is remaining? 2. 2 will be there, right? 2 slash 3. And here already only one empty place was there. We now use this part for one more flow. So again it become 2 by 2, which means what? How I got it? If it is a forward flow, we have to add 1 to it. So when I add 1 to it, it become 2 by 2. And when I add this 1 to it, it become okay. So when I add 1 to it, it become 1, right? 1 is used here. Sorry, once again, I'll delete it. So this part you have the capacity, we have to add it, right? 1 divided by 3. Only 1 is used. And then when you come to this part, already here 1 divided by 2 was the previous. You can draw different graph for every time. So I'm using different colors to differentiate it. But you can draw different graph, and then every time you can use different graph to update this. So now when I add 1 more to it, it becomes 2 slash 2, right? So it's done. Now again we have to say, is there is any more path through which we can send again data from source to destination. So if you see this path, it is again 2 by 2, which means 2 is the capacity, 2 is used. And we already this path is blocked. So here also we can say, I cannot send any more data through this place also. It is also blocked. And so here if you see this path also, it become 2 is the capacity, 2 is used. Here is also it is blocked. Can we send something through this here? So this path is blocked, this path is blocked. So from the source, I cannot start any data from it. So we don't have any other path to go from source to destination. So these are the 3 available paths to move some volume of data from source to destination. And the flow we found is for each path we found 1, 1, 1. So totally what we can conclude is totally through this path I can able to send 3 volume of data. So this is the flow we can send at a time from the source to destination, which means 3 volume of data can be sent through this 3 different paths at the same time. So I can reach source to this S to T, and through this paths I can able to send 3 volume of data. That is the meaning. And one more thing I have to tell you is this network flow. So this is how we can able to find whenever we have a graph. Real time, if you think, for example, we have Karunya universities here, many other PhDs in Coimbatore, Anna universities in Chennai. So you say, for example, we have different places. So if we want to send data, the capacity or the flow or the cable may be of different kinds. So how much volume of data I can able to send from one place to another place, how we can find this through this this way only we can find. So at a time I can able to send a 3 volume of data. I cannot send flow. So one way, I can send through this, another I can send through this, another I can send through this. This 3 way. At a time I can send 3 volume of data. So this way of solving this problem is called as, so you can call it as augmenting path method. Also, this method is called this. You can also call this as
Sam,
Ford. As there is any query, you can also call it as Ford Fulkerson method. So we have solved this network flow problem using, you can solve this method, this you can solve in this way. This method of solving is called as augmenting path method. We are augmenting every time, right? How much you can able to send. So you can call it as augmenting path method, or you can call it as Ford Fulkerson method. So using this method, you can able to find at a time how much volume of data you can solve. So this is one way. You can solve the same method through another method also, another way also. So that method is called as min cut. Okay, using min cut method also, you can find at a time how much volume of data you can able to send. For that, let us draw this diagram one more time. Same diagram, the same diagram. I'm going to draw it again. So we have a source, yes, and we have some intermediate nodes like U, V, and then we have T, and all are connected. So the volume I can send through here is 2, 1, 2, 3, and 1. So now let us see using min cut method how we are going to solve it. Okay. So what is this min cut method? Is we are going to divide this graph. So what are the different way I can able to divide this graph? Is one method is I can divide it in this way. This is one way to divide it. So if I divide it in this way, what is the cut value I will be getting here is 3. Okay, so when I divide in this way, so 2 plus 1 is 3. So this is one way I can able to cut this or separate this graph. What is the other place I can able to cut this graph is this way, right? Here also I can divide it graph. So if I cut or divide it in this way, what is the cut value I will be getting? Cut equal to, so here again you can see 2 plus 1. So 2 plus 1 is 3. So this is another way I can able to cut it. Even I can divide this graph in this way also, right? Which means like this. You can also divide this in this way also. So if I divide in this way the graph, so what is the cut value? 1 plus 3 plus 1. So the cut value will be 5. Is there is any other way we can able to cut this graph or divide the graph? Means yes, you can also do through this way also. Okay, you can divide the graph through this way. If I divide the graph through this way, it is like 2 plus 3 plus 2. So what is the cut value for that? Is cut value equal to 2 plus 3 is 5, 5 plus 2 is 7. So this, I think no other way we can able to cut this. So this is how we can able to cut this graph in many different places, and we found what will be the cut value. Now if you see, then you have to take, so according to the name of this method, minimum cut, right? Min cut, which means you have to take the minimum cut value. So if you see in of all this 4 possible ways, the minimum value you can see is 3. So what is the minimum cut? Minimum cut you can see here is 3. So we got the same answer. What is the 3 means? We can able to send a 3 volume of data at a time from source to destination for the same graph. So when we solve using this Ford Fulkerson method also, we got the total flow I can send at a time is 3. Also using min cut method for the same graph, when I solve it, again I am getting cut value or flow. So minimum cut says that at a time how much volume of data I can able to send from source to destination. So again we got the minimum cut value was 3. Okay, so I hope you got it. So this is one example. Let me solve same thing using another method also. With like not another method, we'll use another example. So we did for this graph, we solved this network flow problem one method using augmenting path method, or we can call even it is Ford Fulkerson method, and another method is min cut method, right? So let us take another example and let us see how we can solve it so that you will understand a little more clearly. So let us go for example 2. Okay, so let me draw another graph. So the graph is like 1, 2, a little bit big graph so that you will be little more clear in solving this problem. So here we have 3 and 5 and 2, and here we have one more node, or we have an edge. Here is 1 and 3. So it is a directed graph. So this is our graph. So now, so who is our source and who is our destination? In order should be 0. So that is what I have already told. In order should be 0. So that can be source. So here if you see, the in order of this node is 0. And what is the out order of this node? It is also 0. So here what we are going to consider is, we are going to consider this is our source node and this is our destination node. So the source node should always have an in degree of 0 and the destination node will have an out degree of 0. So then what we did here, we want to find the path like this and we want to find what is the flow, right? And also one more thing you have to remember is, if it is a forward flow, we can just add, or if it is a backward flow, you can just subtract it. So now initially this is what our condition. So initially we are not using anything out of it. So initially 0 will be there. So which means of capacity 1 we have used nothing. So here also for a capacity of 3 we have used nothing. And for this the capacity is 4. And here also we can say 0. So this is what the initial state. Now we have to find the different paths. So what can be the first path? So we can see the first path I can send through is this direct path I can take, right? So which means I can go from 1 to 2, 2 to 3, and 3 to 6. This is one path, and I have to know what is the flow. So what will you do for that? So what you have to do is, we have to, 1 second. Okay, so here we have to find what will be the flow now here. So further, what will you do? We will be subtracting. So it will be 0, 2 minus 0 will be 2. And here it is 5 minus 0 will be 5. And again 2 minus 0 will be 2. So out of all this, what is the minimum value? 2, 5 and 2. Out of all this, the minimum value is 2. So the flow here is 2. Right? This is what we will be finding. So after we find the flow for this path, then what you have to do? We have to add this flow to this, right? That's what we did earlier. So how will we do? We have to add it to this place. So when you add it, it will be like 2 by 2. Again, you have to add this 2 to this path as well. So when I add it, it will become 2 divided by /5. And here again, we have to add this 2, so it will become 2 by 2. Okay, so we finished it. This we find one path. So if you see now, what you can understand from here is this. So hereafter, I cannot use this path because it is blocked. Why it is blocked? The capacity of this pathway is 2 and it is utilized, right? That's it. We cannot use more than this. You cannot go through this path hereafter. So now we have another pathway also to go through that way. So if you see that, what may be the next path? I can go from 1 to 4, then I can go from 4 to 3, and then I can go from 3 to maybe a big path also you can take, whatever may be the path you can take. So 3 to 2 will be taking another way, then 2 to 5, then 5 to 6. So this path also I can go. Why I didn't choose this path? Because this path is also blocked. Because the capacity of this is 2 and it is utilized. So this path also we cannot use it more. So that is why we came from 1 to 4, then 4 to 3. This way we cannot directly go because it is blocked. The capacity 2 is already used. So I am going from 1 to 4, 4 to 3, 3 to 2, 2 to 5, 5 to 6. So this is what we have written. Now we have to write what will be the flow. So when I write the flow, what we have to do, you hope you remember, we have to subtract it and see. So here I'll get 3 minus 0 is equal to 3 and 1 minus 0 is equal to 1, and here it is 5 minus 2 is equal to 3. Here 3 minus 0 equal to 3, 4 minus 0 equal to 4. So out of all, who have the minimum path? Here it is 3, here it is 1, here it is 3, 3, 4. So out of all, the minimum value is 1. So through this way, I can make a flow of only 1. And then what we learned is this flow should be added. If it is a, so what we learned already, if it is a forward flow, then we have to add it. If it is a backward flow, we have to do the subtraction. So if you see here, 1 to 4 is 1 to 4 is a forward flow. So we have to add this 1 to this. So when I add, it will become 1 by 3. And here, when I add, it become 1 by 1. So 1 is added. And here you can see we are going backward, right? So when you are going backward, already we learned we have to subtract it. We should not add it. So already now we have, what is the size? So already it is 2 divided by 5. So, okay, 3. So we now to this 3 I have to subtract 1. So this is what the final one, right? So to which I have to subtract. So when I subtract it, it is like 1 divided by 5. Okay, if it is a forward flow, you have to add this flow with that. If it is a backward flow, you have to subtract it. So it become 1 divided by 5. And if you go through this, again it is a forward, so it's become 1 divided by 3. It become 1 divided by 4. So this flow need to be added through this path. Okay, so this is the one way. And so any other way we can able to go. So for example, let us see this path. So from the source we can move only to 2 ways. Okay, so this path is already blocked because 2 by 2. Okay, and this path is not blocked, we can come here. But after this, if you see, the capacity is 1 and 1 is already used. So this path is also blocked. So hereafter we cannot move to any other place, right? So it is finished. So I can say 2 plus 1 is 3. So to this path I can send a flow of 3 at a time. So because we don't have any other path. And one more thing you have to remember, this is not the only solution you can have in this network diagram. You can also have another possible way also. I will just write it, but you have to solve and update the graph. What is the another way? So how we started here is, we started like this. 1, 2, 3, 6. That is one path we chose. Then we went through this. This is one way. Another route I can choose it. I can go like this. I'll go from 1 to 4, 4 to 3, and 3 to 6. Okay, you leave this, take a fresh graph of this and do this. So instead of directly going from through this path, I'll do like this. 1 to 4, 4 to 3, 3 to 6. This is one you have to do as a homework, and then this is path. Another path I can use is, so if you see here, you have to find what is the flow. Okay, you have to find and come. What is the another path I can choose is, I can go from 1 to 2, 2 to 3, and 3 to 6. So you have to find what is the flow for this. And one more path I can find is 1 to 2, 2 to 5, 5 to 6, and you have to find the flow for it and find what is the total flow you are getting for the fresh graph of this. Okay, not don't do in this itself. Take the fresh graph of this and find for this part you find what will be the flow. So definitely you should have same kind of flow only. Okay, so this is how we can solve the problem of network flow. So when we have a graph for a networking purpose, we can understand how much you can send at a time. So that is what this problem is. So this way of solving, we did it using two method. One method is augmenting path method, another one is mean cut method. So augmenting path method is also called as Ford Fulkerson method, and another method is mean cut method. So this through this two method we can able to find how to solve this network flow diagram. Hope you have understand it. God bless you.